Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on February 18, 2026, exactly 1 week ago. It introduces a new benchmark called SAW-Bench to test situated awareness, and it reveals a massive 38% accuracy gap between humans and the best multimodal models like Gemini 3 Flash. The paper is titled, Learning Situated Awareness in the Real World. And as we'll see later, the results uncover some surprising failure modes where models struggle to distinguish simple camera rotations from actual physical movement. To visualize this, Figure 1 shows the core challenge of situated awareness. On the left, notice how the observer walks in a straight line, the gray arrow, but constantly turns their head, creating a complex camera trajectory that models must decode. On the right, the radar plot compares performance across 6 tasks, such as spatial affordance and memory. The outer pink region shows near-perfect human accuracy, while the much smaller inner shapes reveal that even top models like Gemini 3 Flash struggle to maintain a coherent spatial understanding. So Figure 2 breaks down the 6 specific tasks included in SAW-Bench with concrete examples. In the center, we see a bird's eye view of the Courtyard Commons, but remember, the model only receives the egocentric video feed, not this map. The surrounding panels illustrate the challenges. For example, the relative direction task in the top left asks the model to locate its starting point relative to the end. Over on the top right, spatial memory tests if the agent noticed objects changing during the clip. Finally, tasks like route shape require identifying the geometric path the agent walked. Well, Table 1 puts those tasks into perspective by comparing SAW-Bench against existing visual spatial reasoning benchmarks. The columns track key features like egocentric perspective, video modality, and specific capabilities such as self-localization. Scanning the middle rows for prior work, you see a sea of red crosses, especially under the specialized tasks on the right. Most previous benchmarks rely on static images or miss the observer-centric focus entirely. In contrast, the bottom row shows that SAW-Bench uniquely covers the full spectrum, combining motion understanding, spatial memory, and action feasibility. Alright, to ensure these tasks are rigorously tested, Figure 3 outlines the benchmark's 4-stage curation pipeline. It starts on the far left by predefining specific camera trajectories, like U-turns or zigzags, rather than relying on random walking. Next, the team prepares meta-annotations for the target tasks. In the center, we see the actual filming phase, where data collectors execute these paths across diverse indoor and outdoor scenes. Finally, the panel on the right highlights the quality review, where they filter out clips with abrupt turns or unstable viewpoints to guarantee high-fidelity data. So, Table 2 presents the main evaluation results, and the findings are stark. The first row shows that human performance averages around 92% accuracy. In comparison, the best proprietary model, Gemini 3 Flash, only achieves about 54%, highlighting a massive 38% gap. The open-source landscape is even further behind, with the leader, Qwen 3VL, scoring just 41%. Scanning the individual tasks, relative direction proves particularly difficult, where models score nearly 50 percentage points lower than humans. Well, Figure 4 illustrates exactly why these failures happen through a case study. On the left, for the reverse route plan, Gemini 3 Flash succeeds because it explicitly tracks every step and turn to reconstruct the path. In contrast, the open-source Qwen 3VL fails by taking a shortcut. It looks only at the start and end frames, missing the movement in between. Then, the right panel reveals a systematic error in route shape. Here, models mistake simple camera pans for physical turns, incorrectly claiming the user walked in a zigzag just because they looked left and right. Moving to the dataset specifics, Table 10 summarizes the scale of SAW-Bench. It lists 786 unique videos, split roughly 60-40 between outdoor and indoor environments. This environmental diversity is critical because, as the results showed, open spaces are not always easier for models to parse. Finally, the bottom row counts over 2,000 total questions across 15 scenes, providing a substantial testbed to ensure the low model accuracy is a consistent failure rather than a fluke. Ultimately, this research highlights a critical blind spot. Current multimodal models lack true situated awareness. They treat video as a sequence of images rather than a physical journey, often confusing a simple head turn for actual movement. Closing this gap is essential for the next generation of robotics and augmented reality. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.